Welcome to the Bluetooth background communication session at Build 2016. Hi, my name is Kiran. I'm a program manager on the Windows Bluetooth team. And I'd like to thank all of you for the excellent feedback that caused us to do this session. We've seen that this was a common pain point for a lot of developers, so we pulled together the content to really show off all the tools, all the background tools that you have in your utility belt when you code up an app. So what are the background affordances, the background triggers at your disposal in Windows 10? There are two main types of background triggers: short running and long running. Bluetooth has three special short running background triggers. The advertisement watcher and publisher triggers were covered extensively in last year's build session, so be sure to check that out. But they're basically how we interact with beacons in the background. If you see a beacon nearby, the Bluetooth LE advertisement watcher trigger will fire, and you'll be able to run a small bit of code. The device connection change trigger occurs when a Bluetooth device becomes connected or disconnected. So again, an event fires and you run a small bit of code. Finally, the GAT characteristic notification is placed on a particular characteristic on a remote device. So take a temperature sensor, for example. You would put a GAT characteristic notification trigger on the temperature value, right? And when that changes, your background task will fire and you'll be able to deal with the new data. A special note about GAT characteristic notification: it is much better and more efficient to use this trigger when there are very low frequency events. So a temperature change, for instance, might only occur every couple minutes. The remote device might only change its value when the temperature value changes for maybe by 1/4 degree. So that might only happen every few minutes, and then we get a background task notification, runs a small bit of code, and the process gets killed. So that's the life cycle of the background task. If your device is going to be notifying more often, that's when you would use a long-running background task. The device use trigger is long-running. So what happens is when you want to use a particular device, and this can be used for sensors and USB devices and all of that, but for Bluetooth specifically, it is excellent to use for Bluetooth LE devices. So you can have a device use trigger on a heart rate sensor, perhaps, that changes more frequently, maybe once a second. And instead of having to get a process spun up every time the heart rate reading changes, you can instead have a common process that's just up the entire time, responding to value changed events from the heart rate. So that's what I want to say about device use trigger. And finally, this entire session is about the RFCOMM connection trigger. The RFCOMM connection trigger is super useful for creating socket communication between two Bluetooth devices. It is what other people would commonly use serial port profile for. A lot of that same functionality is in these APIs. And you can actually do a lot more with it because it's at the protocol level. So that's RFCOMM connection trigger. This entire session is going to go in depth on how to use it. The second topic for this session is actually a very common developer ask as well. We have seen that it is much easier for developers if they're able to connect to devices without pairing. And that is where this year we are unveiling unpaired device interaction with Bluetooth Classic devices. Now, the more common thing that a lot of people want are Bluetooth Low Energy unpaired device interaction. And I'm really excited to announce that we're going to have an insider preview coming later this year for unpaired device connections with Bluetooth Low Energy. So back to Bluetooth Classic, but be excited for Bluetooth Low Energy coming, unpaired device interaction coming later this year. The way we're going to structure this demo, we're going to use a a small chat sample, and this is the one that ships on GitHub, so you can check it out. It's one of the official universal Windows samples. But the key here is it exercises our background affordances and allows you to communicate with a very large range of devices. We're going to show you both the server and the client today, but Windows can be either one of the two when you're communicating with other devices. In this example, your app will register a trigger with the system. So that is the RFCOMM connection change trigger, RFCOMM connection trigger, so that lets the system know two things. One, to advertise your service so that we know that the app is looking for incoming connections from a particular device. And two, it allows us to accept incoming connections on a particular service. So let's say in this case, I'm writing a small chat app. So when I register the chat service trigger, my app will, the system will advertise support for the chat application in its SDP record. So the service discovery is how a remote device finds out what my system supports. So once you register the trigger, the system is advertising support for your app. When I receive an incoming Bluetooth connection from a client device, that's when the system will invoke the background task for your app. In your background task is where you take the trigger and you cast it as a specific RFCOMM connection trigger, and you're able to get the socket. And the stream socket is, this is basic, other basic Windows networking protocols all rely on stream socket, and so Bluetooth does the same. Once you have a socket that represents the connection to a device. And you can proceed to communicate with that device over RFCOMM and with your foreground task. So right now we're in the context of your background task. You can communicate with the foreground task with either an app service, or in this case, we've used a local storage method. So we're just saving things off into local settings. So in the demo, look for three things: how we register the background task and the properties that are required to do so, the way we implemented the background task, and being able to query for the remote devices and connect on the client side. So we're going to show you both sides of the code, server and client. So let's hop into Visual Studio, and I'll show you how we coded up a simple chat client. All right, so we are in Visual Studio now, and we're ready to initialize the trigger. This is how the app lets the system know what service connection we're expecting. In this case, the most important property is the local service ID. This is how your remote device, so the client that is connecting, will decide if your app is supported on the device or not. The local service ID is usually a GUID, so it's uniquely identifiable, and it's the easiest way for a remote device to find support. The second property that we've implemented here is the optional SDP record. And this just gives a friendly name to the SDP record populated on the device. So in this case, we will name it chat service, and the RFCOMM chat protocol will be the service name, but you can give your service any name you'd like. The next piece is just a generic background task pattern where you register your background task. We're using the common background task builder pattern, so you configure it, and then you call builder.register, and that lets the system know that that particular background task has been registered. So when you get an incoming connection on that particular service, so on the chat service, that's when your background tasks run method is called. Now, because this is a long-running background task, it is up the entire time a device is connected. So, for example, the Microsoft Band uses the RFCOMM protocol with Windows. When it gets connected to, the run method is fired, and they have a long-running process to sync their device. So the key thing here is to get the deferral. If you do not get the deferral, your run method or your background task might be terminated unexpectedly. When you do get the deferral, it gives you the flexibility to complete the background task when you want. And I'll show you when we complete them. But in this case, the next step is to cast the trigger details that is passed through the background task into the specific RFCOMM connection trigger type. And from those details, that's where you get two really important pieces of information. The socket, which is the basic object that you need in order to have bidirectional communication, and the remote device that did the connecting. Right? So something connected to the device, you will get the Bluetooth device from there. And the key value that I'm storing here is the remote device's name, which is the friendly name of the Bluetooth device that connected to you. But there are a bunch of other properties on Bluetooth device that might be interesting to you. Once you have the socket, you can use the methodologies of the output and input stream and casting that into and passing that into a data reader and a data writer. And that's how we communicate bidirectionally. Now I'm going to sort of switch contexts. And so that was the server code, right? That's what got the connection and set up the socket. But what did the connecting? That is the client code. Now on the client side, there's another session that we have in Bluetooth that talks more about how to query for nearby devices with the device watcher pattern. Take a look at that session. But once you have a device that is interesting to you, you can query if the device supports the particular service that you're looking for with the Bluetooth device.getRFCOMM services. Now that local service ID that we talked about, that we initialized the trigger with, that is what I'm passing into this call to get RFCOMM services. Because if my remote device supports the chat service, that's the only reason I'd want to connect to it. As the app, I know what I want to connect to. Now, that will return a list of services, and I know that if everything goes well, I will only have one service. So I pick that as my service that I will be chatting on. Once I have the chat service, that's when I can get the socket. Now I used lock here so that this is actually in a UI thread where I'm pressing a connect button. But in this case, I don't want multiple calls trying to get the socket from the same chat surface. I only want that to happen once. So we make sure that this is a blocked call and all the code inside is locked. And once we have a handle to the chat service, that's when we can get the chat socket from there. And like we saw before, once you have a socket, you have bidirectional communication with the device. So now on the client side, we have the socket, and on the server side, we have the socket. The send function for the client basically takes whatever is in the message box and writes it to the chat writer. And the protocol that I'm using is one that I've defined myself, which is write the length of the message and then write the message itself. And that allows the other side, the server side, to guarantee that a certain number of of characters has been transferred over and that they have received all of them. In this case, I have defined my own protocol, and that is what RFCOMM is great for. Any number of RFCOMM devices implement different protocols, so it's extremely flexible. And in the receive loop, you see that I'm basically reading off that same thing. I'm looking for how many characters have you sent over, and then now that I know, let me read that number of characters from the buffer. So that's what I'm doing here, as well as some checks to ensure that my device has stayed connected. Basically checking that the number of characters that the remote device has said they're sending over has actually been sent over. Now let's go back to the server side. So if I send a message in the client, it follows a protocol. When I send a message on the server, it follows a different pattern. And that's because we have the socket in the background task. So instead of writing directly to the socket like we could in the foreground client example, we have to write either to an app service, or in this case, we are using local settings to pass those messages through. So when I send a message, I take the string that was in my text box, and I pass it in to the local settings. And that is so, in my background task, I have a periodic timer that's basically checking every second to see if a new message needs to be sent. And when it sees a new message, it writes whatever was in the settings, the local settings, into the socket, into the data writer. Similarly, when we receive data, what we do is save off that value into the local settings. And what we use here is the progress handle. There are two event handles that are called for a background task, the progress and completed. And we're going to update the progress reading so that an event handler can be implemented in the foreground. So in the background, when we increment the progress property for that background task, the onProgress event handler is invoked. And so we can take the message that was received, retrieve it from local settings, and display it to the user. All right. So that is the long and short of it. The server communicating with a client. Let's see it in action. I already have the app on this device, and it is called the Bluetooth RFCOMM chat sample. So I'm going to have that on this side. And I'm going to deploy to my phone. Okay. And it should get deployed. Okay. The app is now deployed. And so we see you see the phone interacting with my local PC. So I'm going to have the local PC be my chat client. So it's going to look for devices. And I'm going to navigate to my settings page. But on the server side, I need to register the trigger, right? Telling the system that my device is ready and is looking for active chat service connections. So once I've done that, I can navigate to the settings page to be discoverable. And I show up as Windows Phone on my PC. And when I see that, I can connect to the selected device. And now I have an active socket with the device. And that is true because if I go back to my app and I have it in the foreground, oh, it sent an empty message initially, I can type in a message, hello, and it's received on my phone. So we have an active socket going between the phone and the PC. Bluetooth sockets are awesome. All right, send. and it is received on the PC side. So that is the Bluetooth RFCOMM chat sample. Thank you for watching the Bluetooth background communication session. For more API reference and the code samples for this, as well as our other Bluetooth APIs, please check out our landing page at aka.ms/btdevdocs. And to continue watching other cool build sessions like this, check out the other recorded sessions on Channel 9, and continue your learnings about this technology area as well as others on the Microsoft Virtual Academy. Thank you.